now we're on functions. Standard F. F1 and 2 for functions. We're on page 14. We're determining if these relations are functions. And for the graphs, of course, we're going to use the vertical line test. Remember, if I write it here, you're going to write it. So if I reveal it to you, that is something I want you to write down. So number 1, we're using a vertical line. So here's my vertical line. As I slide this across my graph here, does it ever hit a point more than once? Like, as you can see, as I stop, right now it's only hitting this point. Every time I stop or slide it just a little bit more, I only see it hit one spot. It will never hit more than one spot. So that passes the vertical line test, so it is a function. All right, number 2, or the second one here, you can see that, like right here, for example, it's hitting 2 spots, which causes it to not be a function. It's a function if each x has 2 different y's. As you can see, this x value is, well, here's the x-axis. So the x looks like it's -1. So we have the points -1, comma, 2 point something, 2 something. And we also have -1. This one down here is at like -3 something, whatever, right? So this x has 2 different y's. That causes it to not be a function. All right, over here we also have not a function because not every x has just one y. So the answer to this is no. And the last one, since it's a vertical line, that line's hitting every y, right? It hits all kinds of places, so this is also not a function. All right, when we get down here for our tables and such, we want to look for repeated x's going to different y's. Write that down. Okay, as you can see here, my x's never repeat. The y's do, but that's okay. As long as the x's don't repeat, it's a function. The second one here, as you can see, I have 3 going to 0 and 2. That means the vertical line test will fail. It is not a function. The next one's a trick. As you can see, the x's repeat, but look at the y's they're going to. They both go to the same y. Okay, in that case, it's okay. That's just the same point. It's just giving you the same point twice. That one's okay. I don't have 2 of the same x going to different y's, like in this last one. 3 goes to 3 and 2. Can't have that, so that's not a function. All right. When you have ordered pairs, again looking at the x's, just the x's for now, and I do see a repeated x, make sure they're going to different y's. This one goes to -2, this one goes to 1. They are different, which means it's not a function. Okay, looking for your repeated x's. 0 repeats and goes to 2 different y's, so it is not a function. And this last one, again, still looking to see if it's a function. Not if it's linear, that's a different question. You guys know this one's not linear, but we're asking, is it a function? Well, you have to think about what this might look like. We actually did this briefly. When we have x squared, the graph is going to look something like this. Could you just sketch this for me? These are your axes, your x and y. And the graph itself will look something like this. Okay, it's going to be that U-shaped. It's going upwards because the first term is positive. And as you can see, if I took my line across here, it will never hit more than once. So this one is okay. But one that we have not talked about, which is a good idea to look at since we really haven't talked about it, is when y is squared. When y is squared, it's just turned. Okay, it's almost like a transformation. We're going to rotate it. Okay, it's going to look like this. All right, so I'm going to draw a picture on the other side so you can see. When y is squared, it's going to look like this. Y would be here, still x here, but now it's going to be sideways. In this case, it will not be a function. All right, page 15. We're comparing properties now. This was the tough one, but we can do it. Which equation, number one, which equation has the greater rate of change? Well, you guys know rate of change means what? Slope. You guys know that. Okay, and that stands for the letter m. Okay, so we're looking for the m in my equation. When it's written in y equals mx plus b form, the m is the one that comes next to the x. We're looking for m. Okay, as you can see, equation 1 is written in that form, so the m here is 3. But number 2 is not in that form. So take a second, write this down. We need to solve for y first. Pause the video if you need to. All right, to solve for y means to get y all by itself. At this point, there's only one thing hanging out on the same side as y. It's that 2. So to undo the 2, which is being multiplied to the y, we are going to divide by 2. When you divide by 2, you have to divide every term by 2. These are going to cancel each other out, leaving me with y by itself. That's good. And the x term is going to be 5/2. You can change it to a decimal if you'd like to. I'll write it as 5/2 first, 5/2 x. And of course, 6 divided by 2 goes evenly. 6 divided by 2 is 3. If you want to divide the 5 by 2, that's fine, because it does come out nice and even, with a decimal, of course, is going to be 2.5. Right? 5 divided by 2 is 2.5. Okay, so now we have the m here. It's in slope-intercept form, so the m is 2.5. So the question was, which one has a greater rate of change? So our answer is equation 1. Okay. Number 2, which one has the greater slope? Okay, this means which line is steeper. Greater slope means steeper. If we're looking for the smaller slope, we want the one that's less steep. All right, line 1 is this one here. So line 1 is this guy, whereas line 2 is this one. So which one looks steeper to you? Oh, I wrote it down here too. Which one is steeper? Well, look at it. If you were to walk up those, which one would be harder to walk up? That would be line 1. Okay, which table has a negative rate of change? Again, rate of change means slope. How do we find slope from a table? We do the change in y over the change in x. Okay, so the change in y, here I'm getting bigger, right? To go from a -5 to a -4 is getting bigger by 1. Here we're getting bigger by 1. So this is a 1 over 1, which is not negative. So we assume the next one is going to be a negative, but let's double check. To go from here to here, I'm actually getting smaller. If you need to, you can do it this way. y2 minus y1 over x2 minus x1. That's the same thing as this change in y over the change in x, because of course this would be my x1 and my x2, and this would be my y1 and my y2. Okay, So to find this out, I take y2, which is 0.01, subtract my y1, which is 0.1, and divide that by x2 minus x1. And you have calculators for this, so you can do that if you need to. 0.01 minus 0.1 is negative 0.09 over 2 minus 1, which is 1. So there you can see this one has the negative slope, so the answer is table 2. And number 4, Sally types 60 words per minute. Sue types 3,000 words per hour. These are different, right? How much faster does Sally type? So let's think about that for a second. We have Sally in minutes. We have Sue in hours. We have to convert all to one thing. It doesn't matter if you convert them all to minutes or all hours. Either one is fine. I'm going to convert mine all to hours. So Sally, we said 60 words per minute, WPM, words per minute. We're going to change that to hours. Hours per minute. All right, so if it's 60 words per minute, well, how many can she do per hour? It's going to get bigger, right? Because if she can do 60 per minute, there's more minutes in an hour, so we're going to multiply. How many minutes are there in an hour? 60. And that will give you 3,600 words per hour. And then Sue, of course it says it there, types 3,000 words per hour. So if we're comparing these two, who types faster, or actually says how much faster does Sally type? Well, we know Sally types 3,600 and Sue types 3,000. So how much faster? That's subtraction. The answer is 600 words. Per hour, of course.